Good evening, everybody, and welcome to this Young Rail Professionals London and South East Committee webinar on sustainability in rolling stock. This is the first in a small series of events that we're going to be doing regarding rail's environmental credentials. We all know that the railway industry is part of the ability to green the transport sector, and so we're having a few events starting tonight with our rolling stock event. So first of all, a little bit on the Young Rail Professionals. If we can just pop to the next slide. So the Young Rail Professionals is an organisation for rail industry professionals that are starting in the early part of their career, and we're here to promote, inspire and develop the next generation of railway talent and railway leaders. So these are the things that we want to do. We have our committees dotted all around the UK. So I'm Simon Kendler, and I'm chair of the London and South East Committee, and we're focusing events in London and the South East, although of course we're doing everything online at the moment, which means that our focus is also national, and that's a very appropriate thing for the sustainability aspect, because of course sustainability and environmental issues don't really have any borders. So without further ado, I'm going to hand over to my colleague David, who will do the instructions for this particular event, and we hope that you enjoy. Thank you.
Good evening, everyone. We all know that electrification is the best way to reduce emissions in the railway, but that doesn't mean we shouldn't be trying to reduce emissions on the self-powered vehicles while we wait for further electrification. As part of their ongoing commitment to achieving rail decarbonisation targets in the UK, the team at Angel Trains has been working on developing hybrid technology that can help lower emissions, reduce noise pollution and shorten journey times on routes that are yet to be electrified. One example that Angel Trains has worked on to achieve this goal is the self-charging 165 hybrid, which serves as an impactful intermediary solution to significantly reduce emissions by bridging the gap between diesel and full electrified rail as the entire industry progresses towards a net zero carbon future. To discuss this in more detail, I would like to introduce Angel Trains product manager Brian Reynolds, who will take you through a little presentation on what Angel Trains has been doing on this project.
Hi there. Thanks, Simon and David, and welcome everyone. So I am, as David said, one of two product managers at Angel Trains. I'm responsible for the long-term development of Angel Trains' existing fleets. I'm going to talk to you tonight about the ways that in which we, Angel Trains, can contribute to the wider decarbonisation agenda through upgrade and modification of our existing assets. By thinking about how we can reduce emissions from our existing trains, we can not only contribute the decarbonisation effort sooner than would be possible through the introduction of new fleets, but also potentially improve the performance and reliability of those existing fleets. I'm going to split the presentation this evening into three sections. Firstly, I'll tell you a little bit about myself and where I fit with the southeastern region as well as the railway as a whole. Then I'm going to talk about the decarbonisation challenge that has been set for us as an industry. And then finally, as the slide sort of shows, we're going to have a little précis into the self-charging hybrid, the Class 165 project that we're running at the moment. So, give you a little bit of history of myself, as long as the slides move forward. Right, so I joined the railway in 1992, and I never thought I'd be a young rail professional. It was the days of British Rail. Trains looked a bit like that, which is a little bit scary for me now looking back, but that was the modern day. And it was called Network South East. This is at Slade Green, and that's the kind of maintenance we did. It was very dirty. Everything was pretty mechanical. There weren't very many electrical systems, certainly no software. And it was quite interesting to join the railway as an apprentice back then. Looking similar-ish to how I do now, maybe a little bit younger, 20-something years ago. And there were no iPads or mobile phones or anything like that. That was my notebook that I've still got today. But digitization sort of started to arrive in the form of a networker. This was unbelievably modern technology when I started. A couple of days after my first day on the railway, the first networker 466001 rolled into the depot at Slade Green, and it was quite amazing. And we started to get computers, and we started to look at VMIs electronically, and all sorts of technical things, and I started to look a bit older. But things didn't hang around. Privatisation sort of hit. Trains started changing colours. Franchises were awarded, and it seemed to be the new face of rail. And amazingly, we haven't really seen much change apart from all of those franchises and all of those liveries changing. But I realised I didn't want to stay as an apprentice and on the tools for very much longer. I wanted to sort of broaden my education a bit. So I managed to convince the engineering director of Connex to let me go off to university. And after university, I didn't really want to go back to being on the tools, so I got a job in a consultancy. And because I'd been at Nottingham University, I moved with Interfleet Technology based in Derby. Got a little bit typecast in EMC, the Easy Money Club, as some of my colleagues used to call it. So I decided to jump at the chance of working with an operator again. So I moved across to GNER, Great North Eastern Railways, and investigate all sorts of things like fires on dishwashers and the operational railway as a investigating engineer, which was quite entertaining, although a little bit stressful at times. Moved on after that, had a little bit of a career break, going around the world for 6 weeks, courtesy of Land Rover on the Land Rover G4 Challenge, which was sort of an integral part of my my growing up mentally and realizing what I wanted to do in life. And further growing up, getting kids. That's my first daughter some 15 years ago now. So, and popping back to Interfleet Technology to look at some different things because, you know, the focus in life changed and being an operator was a little bit too stressful. So 3 years back at Interfleet looking at maintenance optimization and strategic maintenance. And then I got a phone call from Network Rail saying, got a bit of a project. We over in Wales, we're running out of signalling infrastructure. We need to fit this new kit called ETCS or ERTMS. So turned up there as project manager to fitting the trains, learned a bit more about locos and built a depot. Okay, it's a very small depot, but I was in charge of building a depot and 11 million quid's worth of ERTMS fitment. It certainly stressed me out. Moving on to digital technology and certainly trying to fit very new technology into very old trains. It was a bit of a squeeze. I don't know how many of you have sort of seen some of this kit, but yeah, it doesn't really match very well with old technology, but it proves what you can do. Lots of challenges along the way. That's for another presentation, I think, and also sort of brought me into the infrastructure side of things too. So understanding what we actually fit to the infrastructure. But anyway, then it brought me to Angel Trains. Been with Angel for 8 and a bit years now, and product manager for 3 and a bit. But the question of what is a product is quite a tricky one because it's not just a small section of a train. We take a product as the whole train. So let's talk a little bit about Angel Trains as a background. So we think about an asset of having around about 35 years of life in it. And up until recently, franchise lengths were sort of 7 till 10 years. With the Williams review coming on at the moment, we're not entirely sure what's coming in the future, but Angel Trains is ready for whatever comes. There's a residual value risk for franchisees. They can't hold on to assets because they cease to exist at the end of their franchise. And that's where Roscoe's bring the value. We look at the long term. And as it says there, we've invested £5 billion since privatisation in our rolling stock. So Angel Trains is, you know, around about the biggest. This is 2019. There are 3 big Roscoe's that were formed in privatisation: Angel Trains, Eversholt, and Porterbrook. Back last year, we were 32% of the passenger rolling stock fleet, 4,469 vehicles, and that is starting to sort of increase as well with our Greater Anglia ventures that are slowly coming on stream. And the other there at 16% are the sort of newbies. They weren't there at British Rail privatisation time. The Macquarie's, Agility Train, Beacon Rail, Rock Rail, SMBC, and various others, and they're starting to get bigger. So it's not the original 3, it's sort of 3 and others now. And thinking about future rolling stock, as I said, Greater Anglia, the Adventurers are coming on stream, so we're starting to increase our size, but the others are getting bigger as well. New rolling stock asset models are coming up. So let's talk about Angel Trains and our asset ownership. We have 3 pillars to our business, and the product management team look at that middle pillar, the releasing our existing portfolio. That's where we focus our challenges. And we certainly want to make sure our assets are the best for right now. So let's look at past the acquisition phase. We'll just skip over buying new trains for the time being and think about the operational phase. This is certainly where us as a product team bring our value. And we do think about the whole life, so we also think about disposal, and we certainly think about disposals, retiring our assets as sustainably as we can, either through sales abroad, donations to museums or heritage railways, and ultimately through scrappage and recycling. And it's worth noting that recently our disposals of upwards around 85% of the scrapped vehicles were actually through recycling. So we try and do it as responsibly and sustainably as we can. But as I say, our team's focus, the product team's focus, is around reliability, asset development and refurbishment and enhancement, building towards the future releasing opportunities of our assets. But there are some particular challenges that we face at present in releasing our fleets. Firstly, there's a number of high quality post-privatisation fleets owned by our competitors that have been displaced in recent franchise competitions. These fleets will almost certainly be offered against our fleets in future franchises, concessions or leasing opportunities. Second, as I'm sure most of you will have been aware with your sort of financial hats on, there's been a perfect storm of factors, situations that new trains have a compelling financial proposition, including historically low interest rates, increased competition in the new train market with Stadler and CAF making inroads in the UK and challenging the existing players of Bombardier, Siemens and Hitachi. And there's also those established players having a mature production line. I've mentioned the Adventurers, but certainly follow-on orders of those kind of fleets that are already out there economically become advantageous. And there's also increased competition in the train financing market, as I mentioned, with the new players of Rail, SMBC, Infocap, and others entering the fray. So these factors have combined to bring the leasing cost of new trains down to a level that hasn't been seen for around a decade or more. And in addition, certainly in the franchising world, quality points set up by the DfT incentivized franchisees to offer new trains in favour of existing rolling stock. And then finally mentioned on there, the maintenance cost per vehicle mile now being offered by OEMs significantly undercuts the maintenance cost of the majority of the existing fleets. So if you take all of those factors together, the releasing of existing trains is a very challenging proposition. And at present, evidenced by mass extinction events, such as on Greater Anglia, where our Adventurers are moving in there, Southwestern, and whole fleets or substantial portions of fleets have been replaced with new trains. So take these factors together, and our job at Angel Trains product team of releasing existing trains is extremely challenging. So particularly for our diesel fleets, and that's what we're going to talk about next, the drivers for decarbonisation. That decarbonisation challenge started in early 2018, where the Rail Minister, Joe Johnson at the time, issued a challenge to us to remove all diesel-only trains from the network by 2040. The subsequent task force concluded that no diesel-only by 2040 target was achievable for passenger trains, but it did recognise that decarbonising freight presented a different set of challenges. The task force also noted that compliance with the government's stated target of net zero carbon emissions by 2050, a target which goes beyond the requirement of the 2008 Climate Change Act, was also challenging but achievable. But perhaps more significant than legislation is the increasing pressure that comes from the weight of public opinion. And in a world where people generally becoming rightly more aware of our impact on the environment, a world where diesel bans and emission charging are becoming increasingly commonplace in road vehicles, awareness of emissions from diesel trains is also starting to increase. So we are overall the cleanest form of public transport in the railway, and we're responsible for only 2% of the CO2 output for all of Britain's land transport. We represent less than half of 1% of Britain's overall CO2 output, and our output is set to reduce further as grid electricity is further decarbonised. But when you're standing on Birmingham New Street Station between two DMUs, those low national percentages offer little consolation. So we can't afford to rest on our laurels. We've seen a massive development in electric cars, and hybrid and hydrogen buses are already on our streets. So in the rail industry, we need to work hard to retain our environmental advantage. So thinking about the available traction energy options that might contribute to decarbonisation, this chart's taken from the RSSB research project into decarbonisation of traction energy, and it shows the relative CO2 output of various traction types. There are a few key points that are worth highlighting. Certainly, hydrogen gives zero emissions at the point of use, but it's important to recognise that if we use brown hydrogen with today's grid mix of electricity, we can end up with a well-to-wheel emission that's actually not much better than diesel. Secondly, hybridising existing fleets has a potential to save about a quarter or a third of the emissions that are currently produced by diesel-only trains. And thirdly, gas engines could provide a step change in CO2 emissions if retrofitted in place of diesel engines, but that's a topic for another day. So let's move on to consider traction options that are available for existing trains. Firstly, electrification. It's gaining more traction, no pun intended, and it's currently the only effective way, other than a diesel engine, to move heavy loads or to move at a high speed. And it's encouraging to hear the word electrification is no longer a dirty word in the corridors of the DFT. And we hope that the rest of Britain's transport follows Transport Scotland's enlightened lead and commits to a rolling programme of electrification on major routes. We hope to recognise that the whole industry, we have to recognise that the whole industry had our collective fingers burnt with the time and cost overruns on previous electrification programmes. But it shouldn't detract from the fact that electrification of highly used, higher speed routes is certainly the most effective and most cost-effective way of decarbonising the railway. We do need to recognise that electrification isn't an overnight solution, especially if we want to grow and retain the skills through a managed rolling programme, rather than the boom and bust approach that's been employed in the past. Of course, electric traction is only zero emissions at the point of use, so the grid mix of how electricity is generated plays a big part in the overall well-to-wheel emissions. So at the other end of the power spectrum, we've got battery-only traction. The batteries may currently be constrained to shortish self-contained branch lines, as currently demonstrated by Viva Rail with their battery-only version of the Class 230 multiple unit. That's a converted London Underground rolling stock solution. But as battery power density and charging technologies improve in the future, it's likely that this range will increase in the medium term. However, batteries on their own are unlikely to provide a viable solution over longer distances. So what's in the middle then? In the middle, we've got gaseous fuels, including hydrogen and LPG. Hydrogen, as we've sort of mentioned, is the politician's favourite, with zero emissions at the point of use. We've got to remember that hydrogen's window of opportunity on lightly used routes has operational limitations. So range, for example, hydrogen trains are likely to only have an effective range of 500 to 600 miles between refuelling events, as opposed to 1,600 miles for a conventional DMU. So there's more frequent refuelling stops during the day, more refuelling points, more additional staff, more infrastructure, and probably more trains. And the necessary infrastructure to generate, store, distribute hydrogen as a fuel source for mass transit doesn't exist in Britain at the moment. So if it's supported by joined up government policies on energy, industry strategy, transport, renewable energy, it can all be put together to produce green hydrogen during periods of low grid demand, which is then stored locally and used either to power transport or convert it back to electricity when the demand is higher. An example of this joined up approach can be seen in Germany already. Alstom's iLint is powered from locally produced hydrogen. But as I say, that's going to take time. Transport Scotland recently articulated its vision to use renewable energy to produce hydrogen to power its trains on less densely used long distance routes such as the West Highland line to Fort William, Oban and Mallaig, and the far north lines from Inverness to Wick. So in the meantime, what other options? Bi-modes. We've seen these on the east coast. Trains that take advantage of existing electrification infrastructure where it exists, but switch to independent power sources when you run out of overhead line. So that's diesel or battery. It can eradicate the problem of running diesel trains under the wires, because one section of non-electrified track along the route. However, bi-mode trains are not optimal. You're carrying around two traction systems, only one of which is ever in use at the same time, at one time, meaning you're always carrying around the dead weight of an unused traction system. Hitachi AT300s and Porterbrook's Flex solutions have shown that diesel-electric bi-modes represent a feasible choice across a range of service requirements, from a new build intercity train to the retrofit conversion of regional commuting rolling stock. These trains definitely do serve a purpose. For example, it's got to be a good thing that between London and Aberdeen, services run nearly 400, well, they don't run 400 miles from King's Cross to Edinburgh using diesel power on an electrified railway. But it should be seen as an intermediate step rather than a long-term alternative to electrification. And battery electric bi-modes use battery to power the train through gaps in electrification infrastructure, potentially lowering costs by avoiding the need to electrify complex or difficult areas or areas of historic significance. And that's been shown feasible with the IPEMU train back in 2015. It also shows that last mile situations such as Oxenholme to Windermere or run-through services from Manchester served by electric trains can be possible. So lastly, diesel hybrid. If we need to go beyond the range of battery alone to cover all of the non-electrified routes currently operated by diesel trains, we can use hybrid drives. And these can be either diesel powered with mechanical transmissions, with a battery as a means of recovering braking energy to provide a boost, or a battery-driven electric train with a diesel engine as an onboard generator, effectively becoming a range extender, and that keeps the batteries topped up. Each of these can provide a significant reduction in overall emissions, coupled with the ability to switch off the engines in stations and other sensitive areas. This latter option, a series hybrid, is the arrangement that Angel Trains is advocating, and we'll talk about that very shortly. But just to summarise the outline, thinking of the Network Rail Traction Decarbonisation Network Strategy, or TDNS, just to summarise what we need to do, the challenge that's ahead of us. Electrifying 11,700 single track kilometres of railway, possibly battery traction of 400 single track kilometres of railway, hydrogen for about 900 single track kilometres, and then some 2,300 single track kilometres where hybrid is probably the best solution. The TDNS recognises there are interim solutions required for bridging technologies, and that's where we step in. It's going to take time to electrify those routes, so it's not going to happen overnight, and hydrogen may provide a long-term solution, but you've still got to put the infrastructure in for the hydrogen too. So, hybridisation. Let's talk a little bit more about that. Our specific Class 165 hybrid drive train. We're going to tell you a little bit of a story of how we came from start to finish here. It was born out of the potential repower of the Class 165 and 166 DMU fleet. The engine and drive line on the fleet is expensive to maintain, and it's led Angel with the operators to look for an alternative. The ITT we issued back, well, quite a while ago, wasn't prescriptive, and potential suppliers came back with all types of offerings. But in general, they seem to come back with replacing a big diesel engine with a big diesel engine. They were offering big diesel engines that were complying with the latest emissions regulations, but they were still big diesel engines. The project started well before Joe Johnson's speech, but we felt that another big diesel engine wasn't the way forward. We didn't think that history would judge us very well. So we thought more widely, and we looked for technology that might be transferable from other other technologies or other industries. So we built on technology used in lorries. Hybrid drives seemed to present a number of opportunities. It was a step change in environmental performance. It wasn't zero emissions, but it was a big step in the right direction. It brought benefits in operation cost to customers, cutting approximately 25% of fuel usage, as well as reduced maintenance cost. And it removed some of the least reliable components and systems on the train, when you think about all the hydrostatics that we take off, which I'll show you in a moment. So we have invested a significant amount of money in the first pilot project, and it will be the first conversion of a diesel multiple unit into a hybrid drive. As with many projects in the industry, we're running a little bit behind schedule as to where we would have liked to have been. COVID-19 certainly hasn't helped in the last year, but we firmly believe that this technology is sound. We want to get it right first time, and our technology partner Magtech, who are a new supplier to rail, but who've a proven track record of electric and hybrid conversions on buses, commercial vehicles and military vehicles, will prove to be the right choice. So we sit here tonight with the pilot conversion train stripped at Loram in Derby, and material is being shipped down from our Magtech supplier in Sheffield, and the installation is started. It's not quite running on the tracks yet, but it's not very far away. So we'll give you an overview of the scope of the modification. So this is the vehicle looking from the underneath, and we're removing the existing Perkins engine, the Voith T211 transmission, and the start auxiliaries, batteries, and the hydrostatic system I just mentioned. So those are the least reliable and most maintenance intensive components and systems on the train. In their place, we will be fitting a 400 kilowatt traction motor. In this application, we're going to be limiting it to 300 kilowatts output because the train doesn't need the additional 400 or 100 kilowatts. It produces 4 kilonewtons of torque, enough power and torque to start the vehicle when one of the other vehicles is out of service on the steepest incline in the network, and that steepest incline isn't on Chiltern, so we're easily overpowered on Chiltern. 180 kilowatts of nickel manganese cobalt batteries. We've tried to balance capacity, performance, cost, weight and reliability by scoping those batteries. Traction control system is a brand new IGBT control system, intelligently controlling the power flows, which allows for the regenerative braking, and 2 120 kilowatt engines acting as generators, or as I mentioned, they are topping up the batteries. The system's designed and built with condition-based monitoring and telemetry, allowing remote identification and diagnostic of emerging problems as the train is in service. And the system's modular in design, meaning that the range extender engines can easily be replaced in the future with either more batteries, which will be a pure battery powered train, or gas engines, or even hydrogen fuel cells if the time comes. So let's have a look at the operation of the system. So we can be used in normal mode, which is sort of battery using to drive the traction motors, with the prime mover source and the range extender engines topping the battery up. The power flow between the range extender engines, battery and the traction motors intelligently managed to deliver the demanded power to the traction motor whilst keeping the battery within its optimum charge and discharge cycle. The system can also be operated in battery only mode. The benefit of this is in stations, depots and other environmentally sensitive areas, we can use GPS location and switch the range extenders off. So we have 0 emissions in those quiet and sensitive areas. So in practical terms, the pilot, we're going to geofence all the stations and the approach to London. So we'll switch off the engines as we roll across the North Circular Road, meaning that the last few miles into and obviously back out of London, inside the Mayor of London's ultra low emission zone, will be emissions free. And finally, when slowing down, the system will capture the energy regeneratively into braking capability, charging the batteries, but also reducing brake pad wear and improving particulate emissions and reducing maintenance cost for brakes and other systems. So let's summarise. There are environmental benefits. Overall CO2 emissions reduction of around about 25%, including reductions in NOx and particulate matter, coupled with not losing the benefit of the embodied carbon that's actually already in the train. So we wouldn't be retiring trains early. Passengers will experience better air quality in stations, as the engines will be normally switched off in those areas, and it'll be quieter for passengers on board, as the engines will be at constant revs rather than revving really high and throttling up and down as they do at the moment. There'll be operational benefits, including reduced fuel and maintenance costs and increased range, giving flexibility and reducing the number of depot visits required by the trains. There'll be performance benefits, which are possible through the improved acceleration capability offered by the more efficient driveline, giving the potential for improved journey times and more frequent services. And overall reliability will be improved through the removal of some of the most problematic components and systems on the train, with their replacement with equipment that is inherently more reliable. And finally, the green upgrade path that's afforded by essentially moving to a battery-driven electric driveline, meaning that the range extender or battery charger can be replaced in future without major surgery to the train. So the project hasn't been plain sailing. We've had some challenges along the way. We're being open about that. Magtech's a new supplier to both Angel Trains and to the rail industry generally. And as a new supplier to Angel, both parties have had to get used to working together with a new partner. And as a new supplier to the rail industry, the approvals regime has been completely new to Magtech. So we've had to help them to help themselves to get all of the systems approved. So between ourselves and our partners at Chiltern Railways, we've worked hard to bring the industry knowledge to complement Magtech's technical expertise. It's a completely new design. When we started out, both ourselves and Magtech expected that it would be an evolution and development of their current systems. However, the size and power requirements of a train have meant significant components have had to be designed from scratch rather than being scaled up from existing designs. So it's meant that rig testing, where we did extensive 50% size simulation, wasn't as effective as de-risking the project as we'd hoped. So finally, testing and test facilities. When working on buses and other road-going vehicles, Magtech have got access to a significant area of private land where they can do incremental testing. This isn't possible on a train, so significantly more component testing and integration testing has had to be done offline, away from the train, which has added time. And then the systems have to be fully combined only when they're fitted to the train. So none of this has been insurmountable problems, but it's added to the degree of complexity and that wasn't fully understood at the outset. So, in conclusion, the market for releasing our existing trains is extremely challenging. There's a number of factors combining right now to make that even more competitive than ever. The decarbonisation challenge will mean that radical changes to the way that we power trains on lines that are not currently electrified in the medium to long term. And that means that retrofitting options such as hybridisation can provide stepping stones towards a zero carbon future, providing immediate environmental benefit with no infrastructure requirements, modular approach to future upgrade potential, and whilst we're operational benefits, we can have better fuel economy, improved performance and reliability by the installation of electric driveline. So that's it from me. See, Simon's rejoined us, you must have known. So I'm happy to take any questions, although don't make them too clever or technical.
Excellent stuff. Thank you very much, Brian, for a really interesting look at some of the innovative schemes and projects that are going on, particularly with regard to our existing rolling stock fleet. We've got a few minutes for a quick Q&A session, and a few questions have come in. If you have a question that you'd like to get answered, then just pop it in the questions box on the right-hand side. So one question which is a bit of a consideration is that idea, that stopgap idea. So, you know, is this project going to lead the way in terms of providing a stopgap where the industry won't be able to cover the rail network in overhead line and alternative traction such as battery and hydrogen, or is this going to keep kind of rolling stock companies current but still full of life equipment going, or is it a combination of those things? What do you think?
I think it's a combination of both of those things. I think it would be criminal to scrap trains that are perfectly operationable at the moment just because it's cheap to buy new trains, especially if we don't buy new trains that have got future hybrid options or overhead line electrification options. So yeah, hybridizing basically buys the industry time to think about the longer term strategy. This is medium to longer term stopgap. So yeah, answers both of those questions.
Fantastic. And also we've got obviously we've still got some Mark III based fleets knocking around. You know, you can think of things like 150s and stuff like that. I can imagine that fitting this type of technology to newer fleets, that's for example the CAF fleets that have been rolled out in Northern and that are going to be coming to the West Midlands and Wales, that might be a little bit easier to do, or maybe I'm wrong. But what about those older fleets? Is there a future for them with this type of technology, or is it really kind of for fleets that kind of date from the kind of network of turbos onwards?
Certainly with our asset portfolio, that's where we've been targeting it, because we know that there's still a decade's worth of life left in them. So it makes commercial sense to do that. We could look at older fleets, but yeah, there's a tipping point where you need to, the investment you're going to put into it, you need to be able to recoup that. So yeah, it's a balance, and every fleet could be taken on its face value merits.
Excellent, that's really interesting. Right, a couple more questions here. So continuing on with that theme, in general, what do you think is the biggest barrier at the moment to innovation in rolling stock? What are the biggest hurdles that you're finding, or even across the wider industry?
Interesting. I don't think there's any barriers at the moment. Actually, we're looking at everything. What we need to make sure is that our customers, so the operators and the DFT, our stakeholders, agree with it, and that's what they want. So we will deliver anything that is required. And at the moment, decarbonisation is the biggest challenge out there. We do a lot of innovation with passenger-facing, as in paying passenger customer facing technologies, and I think the industry is doing really well with that. But the big challenge is the underframe stuff, the decarbonisation side of things, and that takes the whole industry. It's not just one or two companies; it's the whole industry working together.
Which beautifully leads on to this kind of final question we've got here, which is that do you think decarbonising the railway by 2050 is achievable?
Certainly the passenger railway, yes. The challenges really are at the higher speed end, and over 100 miles an hour, then it's pretty much got to be electrification. And certainly freight, we haven't, as Angel Trains, haven't looked at that too much, but as an industry, the traction decarbonisation study has shown that electrification is really the only way to move a lot of heavy freight around as well.
Yeah, absolutely. Freight is definitely a big one, given the energy requirements for freight, particularly moving heavy loads up to 1,500 tons at higher speeds. What's the good question? Sorry, a few more have popped in, which is great. So people are still engaged, and we haven't scared them off. Can you talk more about the engine and battery energy management system? Is the transition between hybrid and battery energy operation automated, or is it part of the driver's activities to control?
No, the way we've looked at it is the driver shouldn't have to do anything technological at all. In fact, one of our original scope items was that the driver shouldn't really notice any difference, apart from the speed of acceleration will be better. So some of the drivers that are more sensitive to it will feel that. And we've had to change the brake gauge, because obviously it's not just air brake. We're now regenerating, and therefore the air pressure in the brake cylinder won't go up, because we'll be regenerating. So we've had to put a new gauge in there to say that we are regenerating, and therefore you do have brake force. It's just not air brake force. So the driver won't see any difference. Everything is automated. There's the remote telemetry that I mentioned, that all of that information goes back to central control. But no, it's very cleverly controlled but automated.
That's really interesting because there's a lot of challenges there. You mentioned there's just a geofencing within the ULED's low emission zone in London, the Chiltern runs coming into Greater London area. There's the kind of keeping the batteries in a kind of optimal condition, which can be challenging as well. I think anyone with a smartphone knows that keeping a battery in a decent nick is challenging. And given those factors, what return on investments are required to support Roscoe's investing heavily in fleets such as Angel with this new technology? And has it got anything to do with securing longer franchises or securing a stake in other sectors in the industry?
There's all sorts of factors, and certainly all of the stakeholders have to come together. We're playing our part by doing this trial, and certainly investing heavily in proving that the technology works. But yeah, the technology and the understanding that Magtech bring with the battery technology and management is second to none as far as we can see. So yeah, we're really proud of it, and we're hoping that it proves itself when we actually get it on the rails and start operating it. That's what we're really keen to do.
Excellent, and hopefully there'll be those economies of scale that will scale up to other DMU fleets. At least we can decarbonise those fleets and keep them going, whilst a rolling programme electrification. There should be a rolling programme electrification across England as well, and Wales that should take place as well. So I think we'll finish off with a couple of these questions, a bit more career orientated. A couple of questions have come in, and they're quite similar. So basically, the questions are around what would be a kind of top piece of from yourself career advice, and one of the questions particularly is any tips for a graduate trying to get onto a graduate scheme.
Interesting, yeah. Yeah, because back in my day, there weren't that many graduate schemes, and it was just about knocking on doors. And I was very fortunate that I managed to knock on the right door, engineering director's door, and put my case. And it was just about sales, really, my personal sales of this is what I can do. But yeah, just being confident, listening for opportunities, use the network that you've got around you, talk to people. The infrastructure we've got now with LinkedIn and other professional platforms are just amazing compared to where we were 25, 26 years ago. So you had to know the right people back then in person, whereas now you can electronically introduce yourself. So yeah, use every tool in your box.
Definitely, that's some good advice there from Brian to you guys that are considering careers in rail. The other thing I would say, obviously, is that as we're a Young Rail Professionals event, and I'm chair of one of the committees, is to obviously sign up to Young Rail Professionals. It gives you a connection to not only industry leaders such as Brian, but it also gives you connections to those such as yourselves who are either wanting to get into the industry or are early starters in the industry, such as myself. So we're all here to support each other. That's part of that, developing the next generation of talent, which leads me nicely on to say thank you to Brian for attending and speaking at this event, kind of first of our series of sustainability events focusing on rail. Of course, YRP is putting on as many events as we can given the current situation. So I'll just give you a bit of a lowdown on a few of the events that we've got in the calendar. So in a couple of weeks, we've got a busy week, the week beginning the 23rd. So on the Tuesday 24th, myself and my London South East Committee colleagues will be back again to do a sustainability in infrastructure event with some folks from Arup talking. So that's going to be coming up in 2 weeks' time, Tuesday 24th. And the Rail Age Quiz, being hosted by Sir Peter Hendy, the chairman of Network Rail, is going to be taking place on Wednesday the 25th. So you can find the details of that on our events page on our website, which is www.youngrailpro.com. Goodness, it's been a long day. And on the 26th, there's also the Heritage event, which is focusing on bridging the gap on the Great Central. For those that aren't aware, the old Great Central Steam Railways, there's a gap in Loughborough where the Midland Main Line goes through it, and there's aspirations to connect those bits up. So if you're interested in kind of new infrastructure, but heritage sector as well, then that's definitely something worth signing up for. It's all on our website. We're also on the LinkedIn, if you find Young Rail Professionals, and we're also on Twitter at Young Rail Pro. We'll be putting out stuff about our new events. There'll be more events coming up as well. Keep an eye out. Sign up on the website. It's free to be a member of YRP, and this webinar will be being uploaded for future reference. So if you've got any anything you want to refer back to, the clever systems that are going to be taking place, any details, then you can watch that back on our YouTube channel. And again, just keep an eye out for that on the website when that will be going up online. So that is it from myself and from Brian and David. So thank you very much for joining us, everyone. We hope you've had an interesting time, and we look forward to seeing you at the next event. Good evening.